Okay.
Hello, my name is Sam Roberts. I'm a car geek. I work on cars as my passion, internal combustion engines. I'll probably reference ICE in the presentation, internal combustion engines, as an abbreviation. Yeah, so I've been working on cars for essentially my whole life, and I'll get into that a little bit later. So it's kind of like an overview of why we need engines, internal combustion engines. So I guess they're applied to anything and everything really in the world. Like for instance, an old airplane engine, all of these are pistons. It's in a circular configuration, and they spun the blades on the engine or on the propeller. They got us through the war. They get us from A to B. They can convert chemical energy to mechanical energy to electrical energy. So a lot of these generators, for an example, they power a lot of things portably, so you don't have to have extremely long extension cords. They're used for basically a lot of things that we have in our daily lives. So for my essential question, I asked, is the V8 engine on its deathbed? That's the engine I grew up with, is a V8, and I'll explain that later. And I read a lot of articles that say V8 engines are dead because of Tesla, for example. Electric hybrid power is the future. But I said no, they're not on their deathbed. They're going to be around for a long time. So one of the reasons I said culture. There's this company called Texas Speed and Performance. They religiously build V8 engines. There's a lot of shops like this out there that build engines or build performance parts for V8 engines only. And there's a big car culture for V8 engines. Like they have old Thunderbirds or old Mustangs that they treat as garage queens. That's what we call them. They don't drive them. They keep them in pristine condition, and they take them to car shows, and they push their cars on youth, such as myself, when I was younger, and when I went to car shows, and I thought that was the coolest thing, and I feel like, and I know a lot of little kids think that's the coolest thing like I did. And another reason they're not going to die is the capabilities. With hybrid power nowadays, they push limits. This is a McLaren P1. This lapped the Nürburgring faster than any car has about 4 years ago that it did. And now there's faster engines like V10s that have lap records for daily drivers. I forget the specific term. But with hybrid powers, hybrid technology, the V8's not going anywhere. And also the performance, V8s have a very broad power band, which means they deliver power extremely smooth. With like twin turbo V6s, they start on the low end, they don't have a lot of torque, and then the power pushes you back in your seat when the turbochargers spool up and kick in. And so that's, for a daily driver, that's not a very comfortable ride, because you put your foot down, you start out slow, then your head jerks back into your seat when the turbochargers kick in, whereas a V8 doesn't do such a thing because the power band is so wide that it just smoothly delivers the power and then to the next gear and just keeps going. We go my history with cars. So my history with cars started with my grandpa and my uncle. So this is my grandpa Gary. He died about 6 months before I was born, and so I picked up a lot of his junk that he left in his garage, or his junk that he left in his garage, which was, one of them consisted of this hot rod. He called it Tasmo. It was a 23-foot tall T Ford. If you guys want to pass this around, take a look. That was the car that I grew up with for a long time, and I worked on it with my Uncle Charlie. He was the biggest influence in my life on cars, because they're brothers, if you didn't pick that up. He was the biggest influence in my life, and he passed away last year, and so I'm the last one in my family that cares about cars. And so we'd work on Casmo for hours every weekend. We rebuilt the engine. We do anything and everything on that car. And that was how I devoted a lot of my time in my childhood. If you go down. So that's my Uncle Charlie. That's my Grandpa Gary. That's Uncle Jimmy and Uncle Eddie. That's the only part of my family that cares about cars anymore. And all of them are gone now. So I am the last one. But I met Jimmy and Eddie. I met them twice, and those were one of the most fun weekends of my life, because it was 12, 14 hours a day. We bought an old Mustang. I think this was when I was like 6, and we restored it in a weekend. We repainted it, we rebuilt the engine, we did everything on that car. And that is one of the most vivid memories I have of my passion, is just rebuilding an old, I think it was 66 Mustang. And that really just boosted my passion for this and why I love doing it. And then this is my Uncle Charlie and my Grandpa Gary. So here's a car. Their dad, my great grandpa, was a car junkie, just like I am, just like they were. And so I'm really glad they pushed their passion onto me. And yeah. So this is my car. Go down a little more. It's nothing fancy. It's a 2000 Land Cruiser. They sold 2,000 of them in each state every year. It's nothing fancy, but it's one of the most important things I have right now. It's my freedom, basically. I spend a lot of time on this car, and so it has a V8, the best engine ever made, a V8 engine. If you say otherwise, I disagree. Yeah, a V8 engine. This is a very simple mechanical engine for a V8, 32 valve, 4.7 liter, nothing fancy. And that's why I enjoy working on it so much, because if you break something, you know what's wrong. You can figure it out, you can replace it. It takes a lot of time, and that's one reason a lot of people don't like working on their own cars, because you drop a 10 millimeter into the engine bay, it takes 3 hours to get it out. And so I do all the maintenance on my car. I do oil changes, air filters, heads, whatever needs to be done. So at around 275,000 miles that the engine had on it, me and my Uncle Charlie rebuilt it my sophomore year, because it struck a valve, and I'll explain that later, but your car can't really run with a bent valve. So we rebuilt it. It took about 2 weekends to do it, but it was all fixed. We put new piston rings in it. We did 2 new heads, timing chain replacement. What else did we do? Replaced the oil pan, just simple things that it needed to be done because it has such a stupid amount of miles on it. And so it's been running great for 20,000 miles since we've done that. And so now it has about 295,000 miles on it. And I plan on keeping this vehicle for as long as I live. And if the engine breaks down again, I'll fix it. Yeah. You go down a little bit. Yeah. So on the weekends, I like to go to the junkyard. It sounds kind of trashy, right? Yeah. I spend 4 hours a weekend sometimes just tearing apart a car. And if you click that. So yeah, I did. Turn it down. something I really enjoy doing. You pay $2, you get in a junkyard, you waste half the day taking apart an engine. And I really enjoy this passion because I learn things every time I go out there. Like, I'm by far no expert at this because there's just so much to learn. There's so many different engines out there. And it's just something that kind of relieves stress. I just bring a speaker out there, I put some music on, and I just tear away at it.
So when you go to the junkyard, you just take what you want?
Yeah, you can. You have to pay for a lot of the stuff. Like, I was gonna bring some heads in, but that was like $40. But I have a lot of stuff in my room from the junkyard that I clean up and just kind of put on my dresser, put things on top of it. And usually when I go out there, I take things apart in an orderly fashion for the most part, so that if somebody wants to come and pick something up, the bolts are still there. But yeah, you go in, I think it's $2 to get into the junkyard, and then you can spend all day in there doing whatever you want, really.
Where's the closest one to here?
It's like a few miles. If you go to Sunsplash off of Eureka and take a right, I don't know what road it is. It's just right there. It's the Pick and Pull is what it's called. Yeah, Taylor. Yeah, so it's pretty close.
By Calaman's over there?
I think so, yeah.
Yeah.
Yeah. So yeah, that's basically my history with this stuff. And so, I thought I'd kind of try to teach you guys something. I did really basic parts for an engine. This is a 2JZ. It's a good engine. They were stupidly overbuilt for what they were from the factory. And you can boost these things up to 1200 horsepower stock. And then you can build the bottom ends, and they're stupid fast. Here, let's go down. So, the structure of an engine, kind of one of the most important parts, is, so you got inline, and you got boxer engines, and you got V configurations. So these are the V configurations. They're at a 90-degree angle from each other, the banks, and that is extremely important because they counteract each other. There's primary forces and there's secondary forces when the engine when they fire, when the spark plugs fire, and so V configured engines are super smooth because they counteract each other. When one cylinder fires, another one fires, and those two forces enact into the crank, and they counteract each other. That's another reason why there's not a lot of vibration in those engines, why they're really smooth. And you got boxer engines like this. It's like in the WRX. Those are nothing special about them. They're all right. And then you got these. This is what powers most Porsches nowadays. They're flat sixes, or flat six, boxer sixes. They're super powerful engines for what they are. Naturally, or not naturally aspirated, but the Porsche 911 GT2 RS has one of the most powerful engines for displacement. I think it makes like 172 horsepower per liter. And so those are super efficient engines when you're trying to get power out of something small. And so the configurations, just the makeup of the engines basically. Yeah, go down. And so there's two basic engine, I don't want to say configurations, but the way that they fire. So first we have two-stroke, which is a really primitive engine now because it wastes a lot of gas. It burns oil. And so these power a lot of like dirt bikes, go-karts, small things, because they're not efficient. They don't put super big displacement two-strokes into a car because that you'll just waste gas and burn a stupid amount of oil. So a two-stroke has three strokes, even though it's called a two-stroke. You got the power stroke, and then the scavenging is when excess gas goes out the exhaust, but this creates a low pressure, and so the atmospheric pressure pushes the excess gas back into the combustion chamber, and then the compression compresses the fuel and the air, and then the spark plug pushes it back down. And those are the basics of a two-stroke engine. Now, four-stroke engines are a lot more advanced than two-stroke. They have a lot more moving parts, and that's what your car engine is. You don't have a two-stroke engine. So there's intake, stroke, compression, power, and exhaust. So the intake brings the air and gas into the combustion chamber through the intake valve. Then the fuel and air is compressed and then ignited, and that pushes the cylinder back down, or the piston back down, and creates that mechanical motion. And then the exhaust stroke pushes the burned fuel and air out, and that just goes into like catalytic converters and out the back of your car. And so octane rating was really important. Nowadays, it's not super important because you have these things called knock sensors. And so knock is just when, let's say your car has 295,000 miles on it and you've never done anything to it. And so you have carbon buildup on the sleeves, on the walls of the combustion chamber. And so if you buy the wrong gas, then, okay, actually I should go back. Octane refers to the amount of heptane and then ethanol, I believe, that's in gas. And gas isn't just like oil sucked out of the ground and put into a pump. They refine it, and then they add a lot of additives to it now because of emission ratings and a lot of outside variables. And so octane rating just refers to the amount of compression and the gas can go through before it ignites on its own. And so for diesel engines, the octane rating is super low because diesel engines don't have spark plugs. Diesel engines ignite through the just the compression of the gas. And so diesel is really cheap, or relatively cheap, but it's the lowest octane that you can get. And then so for regular cars, you got like 87, 89, and then like 91 in California. And so that just refers to that refers to like what I was saying, the compression ratio it can really withstand. And so when you used to buy gas, you'd have to pick the correct gas because there weren't such thing as knock sensors. And then the knock is just the carbon buildups that I was talking about. They trap gas on the side of the walls, and then that compresses the gas in a weird area, and then they prematurely ignite because they bought the wrong gas, and so it compresses. Compression ratios. Actually, I'm gonna draw a diagram. Can I draw a diagram?
Please draw away.
All right. Okay. Let's see how this goes. So this is the combustion chamber, right? Got the little piston in here. Oh god. The rod. Okay, and so this is the displacement of the cylinder. And so let's say we have 6. Okay, we have six little segments here. And so this is the displacement. They have 6 out of 6 open areas, right? And so when the piston goes up, then you have one little segment, and so that's 1/6 of what you originally had. And so that's what refers to as a compression ratio of 6 to 1. It compresses all the air and all the gas to 1/6 of the original amount that was in there. And then that compresses it so much, it heats it up. It just needs a little spark from the spark plug up here to just shoot it back down. And that's kind of what a compression ratio is. And so, let's say you have let's 87 gas, right? 87 octane. And that can only withstand a compression ratio of 4 to 1. So, the gas ignites up here. And so that ignition starts to push down, or the combustion pushes the piston down way before it's ready to be pushed down. And I'll show you what happens when misfires like that happen later. So that's a compression ratio. And these two are just connected because octane is just the resistance of knock that it can withstand. If that made any sense. So, let me go up a little bit. I have favorite engines. I'm weird. I'm a car guy. All car guys have favorite engines. Tiger, what's your favorite engine?
My favorite engine is the rotary engine.
There you go. So.
Nice job, Tiger.
Alright, so my favorite engine is from the Shelby GT350, the 2014 model. Has a 5.2 liter flat plane crank V8. And it pumps out some series power for a V8. I'll explain what a flat plane crank is later. Okay, go down a little bit. I would suggest this video if you like learning about flat plane crank V8s. Anyway, go down. 3 liter 2JZ, 4.8 liter V10 in a Lexus LFA, flat plane crank V8 again from Ferrari, and then the original Dodge Viper V10. Yeah, those are my favorite engines. We go up to components. We'll go through this pretty quick. So you got the cylinder head, you got the engine block. The engine block is the base, it's the foundation for an engine. You got the heads that go up here, and they seal off the combustion chamber. And so these are the valves. This is a 2 valve per cylinder. And so intake, exhaust valve, and I'll show you where pushing goes down in a sec, down a little bit. Like I said, the valves, this is what they look like. They're nothing special. They just go down. The fuel, or the air, if it's direct injection, goes into the combustion chamber, goes back up, and then the exhaust valve lets the exhaust out. And then spark plugs ignite the fuel if you choose the right octane for an older car. Go down. Okay, so these are injectors. If you have direct injection and or port injection, this is what they use. They just squirt a little bit of gas into the combustion chamber, compresses, and then it ignites. Then they leave the chamber, and they inject again. They're little squirt guns, basically. Go down. So camshaft, this is what, go down a little bit, right there. So we have an overhead cam, and so that's intake, exhaust. They just push the valves down so your engine can operate. So that's overhead cam. They got push rod, which is in like LS engines. And so the cam is right here in the valley of the engine block. And these are this push rod. So there's little push rods right here that go up to the heads. There's a rocker here and here that push down the valves instead of the direct contact with the camshaft. There's the rods, the rockers, and then the valves. So the pistons that I was talking about, main piece that goes into the engine block, they compress the fuel and they shoot back down. This connects to the crankshaft, and that converts the mechanical energy up there into, or the chemical energy to the mechanical energy. These are the connecting rods. That's the piston. That's the rod. They connect piston to the camshaft. or crankshaft. So my favorite thing is a flat plane crank V8. Real quick, cross plane, because it's like this, they're connected 4 places, it's a cross. Flat plane, every 180 degrees, the crankshaft turns, another piston fires. And then a sump oil pan has an oil pump, lubricates your engine so it doesn't heat up and blow up because of the friction. Back up.
Yes. Here's your final thought.
Okay. It's my passion. I spend too much time on it. I shouldn't waste as much time in a junkyard, but I suggest you go and try it. Go tear a car apart. It's one of the most fun things I think I've ever done, and I suggest that you guys definitely go relieve some stress. Just tear a car apart.
Let's go to the junkyard. Nice job, bud. Thank you.